Back in your trigonometry class, or potentially your algebra class, you talked about conic sections in the rectangular coordinate system. In this video, we'll introduce conic sections in the polar coordinates. You'll see a few familiar definitions and maybe some new ones. F is going to be a fixed point called the focus, and L is a fixed line called the directrix. Here we can have x equals L or potentially y equals L depending on the situation. And E is a fixed positive number called the eccentricity. The eccentricity E is defined here. Essentially, it's the ratio of the distance from F to the distance from L. That is your E, or eccentricity. And we have three different situations or cases. We're looking at the ellipse if the eccentricity is less than 1. We'll be looking at a parabola when E is equal to 1 and a hyperbola when E is greater than 1. Now, if you don't have those memorized, they can be somewhat easy to confuse. The way I remember it might sound a little silly, but parabola is kind of the most basic. It's the shape that we've seen since our first algebra class. So the most basic parabola, E is equal to 1. I think of hyperbola, I remember the word hyper and greater. Greater than kind of sounds like hyper. That's just the way I remember it. And that leaves the ellipse for being an eccentricity of less than 1. Again, I know that sounds silly, but that's the way my silly brain remembers that. Up next, we have a theorem which defines the form of a polar conic. We have R equals ED divided by 1 plus E cosine theta, or we could use the same thing, but instead of cosine, we'll use sine, and we'll look at different situations on what that does and how that affects the graph. Again, E is the eccentricity. D is the distance from the focus to the directrix. So we could have x equals d or y equals d. Again, those are the equations for the directrix. So d is coming from those values. In this example, we want to write a polar equation of a conic with the focus at the origin and the given data. We're looking at a parabola and the directrix is x equals 2. I personally like to draw a quick sketch off to the side just to give myself a visual. We have the directrix at x equals 2. So that's this vertical line. We have the focus at the origin. So here's our focus. And we know it's going to be a parabola. So just a very quick sketch. The parabola will look something like this. Now to start creating that equation. Notice that the directrix is to the right of the focus. That tells us we're going to be using the form plus E cosine theta in the denominator. And since we're dealing with a parabola, we know the eccentricity, E, is 1. So going to our formula, R equals ED divided by 1 plus E cosine theta. Now we'll just plug in what we know. E is 1, again, for a parabola. D is 2 from the directrix. 1 plus E, again, is 1 for being a parabola, cosine theta. We can simplify that. we get 2 in the numerator and 1 plus cosine theta in the denominator. That means the equation is r equals 2 divided by 1 plus cosine theta. And this time we will write a polar equation of a conic with the focus at the origin. And we're looking at an ellipse. Eccentricity is 2/3, and we have one of the vertices. Once again, I like to sketch something off to the side just to have a visual as to what it might look like. We know the focus is at the origin, and we know the vertex, one of them, is at 2 pi. Again, that is a polar coordinate, so the angle pi is over here, 2 units away from the focus. That means our shape is going to look something like this. Again, not perfect, just a quick sketch. And we know it's a little oblong because the eccentricity, remember eccentricity is between 0 and 1. When you're at 0, we'd be looking at a circle. And the closer you get to 1, the more oblong the shape or ellipse gets. Next, let's start with the generic equation. R equals ED divided by 1 plus or minus E cosine theta. We are looking at cosine since the major axis is the x-axis or the polar axis. Now let's plug in some information that we know. We know that E is 2/3. We're told the eccentricity. 1. Now we have to ask, is it plus or minus? Notice that the vertex is to the left of the focus. That means we're dealing with minus E cosine theta. And we don't know D. So our first goal is going to be figuring out what D is. And to do that, we can use this additional point, the vertex that we were given. We'll plug in the coordinates here, the r and the theta, and use that information to help us find D. So at this point, r is 2. 2 equals 2/3. D we do not yet know. That's what we're looking for. 1 minus E is again 2/3. Cosine of theta is pi. So now we have everything we need. We just got to simplify that and solve for D. 2 equals 2/3 D. 1 minus 2/3 times cosine of pi. Think about your unit circle. That is -1. We now have 2 equals 2/3 D divided by 1 minus -2/3 times -1 is positive 2/3. 1 plus 2/3 will give us 5/3. So continuing with that, let's take that up here and do some solving. If we cross multiply, we'll get 10/3 equals 2/3 D. And then multiply by 3/2 on both sides. If we multiply both sides by 3/2, on the left we will get 5, and on the right we get D. So we now have D. Going back to the generic equation, R is equal to 2/3 times D, which we found to be 5, divided by 1 minus E, which we were told is 2/3, cosine theta. And now let's clean that up to make it a little prettier. We can multiply the top and bottom by 3 to get rid of those fractions. R is equal to 10. And in the denominator, we get 3 minus 2 cosine theta. And we now have the equation of the ellipse. In our last example, we want to again find the polar equation of the conic. The focus is again at the origin. This time we're looking for a hyperbola. Eccentricity is 2. Directrix is a polar equation. R equals -2 secant theta. Once again, we will start with a sketch. We know the focus is at the origin, and we're given the directrix, but the directrix is polar. It may not be obvious right away what that is, so let's do a little bit of work off to the side and see if we can figure out what that looks like. Secant theta we can write as 1 over cosine theta. So R equals -2 times 1 divided by cosine theta. Cross multiply and we get R cosine theta equals -2. And recall that R cosine theta is simply x. So we have x equals -2 as our directrix. So with that, we can get a quick sketch of what the hyperbola is going to look like. Again, not actually necessary, but I like to see it. Helps me visualize what we're going for. Next, we'll start with the generic equation. R equals ED divided by 1 plus or minus E cosine theta. Again, we're using cosine. Next, we can plug in some more information. We know that E, we are told, is 2. The directrix we found to be x equals -2, so that means D is going to be 2. Remember, D is just a distance, so it's going to be positive. Then we have 1 plus or minus. Which one is it? Since the directrix is to the left of the focus, we are going to use minus E cosine theta. And E again is 2, so we have cosine theta. And simplifying this, R equals 4 divided by 1 minus 2 cosine theta. And we now have the equation of the hyperbola.